Alright guys, so in this video I want to teach you about different types of collisions and the types that we're going to see in this class. Now this does connect with momentum because remember we said that even in a collision, momentum is conserved. Now we're going to talk a little bit first here about energy. Now we haven't done conservation of energy yet, we'll do that next semester, but right now you should be aware of something called kinetic energy. You've probably talked about that before in a previous science class, maybe back in 7th or 8th grade. Kinetic energy is the energy of motion. And any object that has mass and speed will have kinetic energy. All right? The more mass that there is, the more kinetic energy it has for a given speed. The faster it's going, the more energy it has for a given mass. Now, we can put this all together in an equation that is that the kinetic energy equals 1/2 mv squared. And you may have even seen that before, where we have 1/2 multiplied by the mass of the object. Like I said, something bigger with the same speed will have the same mass, and then times the velocity squared. So the velocity is actually a little bit more important than mass here, but they are both important to calculate that kinetic energy. Now, most of the time, when things collide, energy is lost. Now, how is it lost? Well, energy can be lost in a variety of different ways. Energy can be lost due to sound, right? And that's one of the things we'll talk about next semester is how exactly does sound work? What is it? Well, one of the things that sound does is it transfers energy, right? The way that sound works is that something causes the air to vibrate, and the air vibrates, and then it causes your ears to vibrate. Now, in order for that to happen, there's got to be some energy there. And so sound requires a transfer of energy. So kinetic energy can be lost if you hear a sound. Now, sometimes energy is lost as heat, right? Like when you rub two things together, there's some friction going on. Energy can be lost as heat because that's a different type of energy. Now, sometimes energy goes into deformation, right? Like when you have a car crash, those two cars are going high speeds, or maybe one of them is going a high speed, and when they run into each other, the cars get messed up. They change their form, they change their shape. That's what we call deformation. And so that can be where some energy goes. So energy can go into all of these different things, right? But the point is that kinetic energy in a collision does not have to be conserved. You can lose kinetic energy. Now, that's what we're going to talk about right now. Most of those situations where we have a collision is what we call an inelastic collision. Now, in an inelastic collision, kinetic energy is not conserved. All right? Now, you may remember that when we talked about momentum, we said that the sum of the momentum's initial has to equal the sum of the momentum's final. And that's what it meant when we said that momentum was conserved. Well, in most collisions, the sum of the kinetic energies before is not equal to the sum of the kinetic energies after. And if those two kinetic energies are not the same, then it is what we call an inelastic collision. Now, there is a special type of inelastic collision called a completely inelastic collision. And in a completely inelastic collision, not only is kinetic energy not conserved, but the objects actually stick together. Boop. Now, we've actually seen some of these already, right? Remember the example that I gave of me skating down rolling down the sidewalk on my skateboard and running into a kid and grabbing that kid, and we move along at the same speed? That is an inelastic collision because me and the kid move along together. We stick together afterwards. Now, they don't have to be completely stuck together, just need to move along together. The example about the dirt being poured into the train, that was a completely inelastic collision because after the dirt collides with the train, they move along at the same speed. So that would be a completely inelastic collision. So if the two objects stick together, then kinetic energy will not be conserved. Anytime that it is inelastic like that, anytime it's completely inelastic, the kinetic energy will not be conserved. The initial kinetic will not equal the final kinetic. And now we do want to look at a very special situation, which is the elastic collision. So in an elastic collision, kinetic energy is conserved. Now, of course, what that means is that the initial kinetic energies, if we add them all together, will equal the final kinetic energies. Now, most of the questions that we look at in this class, we're going to look at momentum first because momentum is always conserved in a collision. And then with the information we have at the end, we will determine if kinetic energy is conserved or not. And so we're going to be doing this idea of we're going to check the sum of the kinetic energies before and the sum of the kinetic energies final. And we're going to calculate that kinetic energy by doing 1/2 mv squared. And you'll notice that it needs the same information as momentum. Momentum needs mass and velocity as well, but this is a different relationship between mass and velocity. These are both important quantities. Now, we're not going to dig into this too deep right now. We just want to make the understanding that in some collisions, energy is conserved, and in some collisions, kinetic energy is not conserved. Now, I keep saying energy is conserved, but energy is always conserved unless it's turned into mass. Sometimes energy is, quote, lost, but in those situations where energy is lost, it's just turned into something else. It's turned into sound, heat, changing the molecules in the object. That would be deformation. All of that can be somewhere where the energy goes. All right, now we're going to go ahead and move on and look at a couple of examples now. So let's go on to the next video.